Hi guys, welcome back. In this video, we're going to be doing the exact opposite of what we did in the previous video. So if they give you the roots of a quadratic or a cubic equation, you're going to be able to find the polynomial. So you're going to go backwards from being given the roots and you're going to give them the polynomial. So now first question, we've been given two roots. We've been given Z1 and Z2. It's important to notice that they occur in conjugate pairs. That's going to be useful later on. Generally speaking, with complex numbers, we often use the letter Z instead of X, but don't let that throw you. So we're going to use the formula that says Z squared minus Z times the sum of the roots plus the product of the roots is how we can find the quadratic equation. There is a second method using the factor remainder theorem. I will show you that also. So in this case, I'm going to say that the sum of the roots, I need to add them together. So that's the first one. Then I need to add it with the second one. Plus the product, which means I need to multiply them together. And I'll do that here. If you want to do your workings out slightly apart, because it might get too messy if you're trying to do it all together. One thing that I really notice is, though, even if you do it separately, you want to work in full lines. Sometimes when I'm marking IB students' work, they have kind of written this side but not equal to 0, and that means that they can't get the method mark. So try and work in full lines, but if you need to, do some work on the side, but put it back into your equation. Okay, so let's add these together. Because they're conjugate, the imaginary parts would actually cancel out. I've got plus 4i minus 4i. That would be 0. 3 add 3 is 6. Now here I need to multiply these out. And remember, you can check out the first series where I teach you how to multiply brackets with complex numbers. That would be 9. That would be minus 12i plus 12i. Now, if you multiply a complex number with its conjugate, it will always be a real number because these will cancel out. And that would be minus 16i squared. So that's going to cancel with that. So I squared is minus 1, so it would be 9 minus minus 16, so it would be 9 plus 16. Okay, so it would be z squared minus 6z plus 25 equals to 0. So this would be the quadratic equation, which would have these roots. The second method, method 2, would be able to use the factor and remainder theorem. So if we know that these are the factors, then the roots must be z minus the factor and z minus this one. And what you could do then, if you'd forgotten this formula here, is you could simply expand this. The expansion might be a little bit messy, but this method would definitely work, but it would be a little bit longer. You simply convert the roots into factors and then you expand the expression. In the second example, we've only been given one of the roots. However, if we think back to what we learned in the previous video, if we know one of the roots, we can find the second root because we know by default it must be its conjugate pair. So in this case here, the conjugate pair would be, I would need to change the sign on the imaginary part, leave the real part exactly the same. Then I can use the previous formula. That would be the sum of the roots plus the product. So the sum of the roots would be 1 minus I, say that's the first one, added with plus the product of those. Okay, so let's simplify that expression. So minus I plus I would be 0, 1 add 1 would be 2. And here I need to multiply out these brackets. Now remember, in the previous series we covered how you could expand double brackets which include complex numbers. So 1 times 1 is 1, add I, minus I, and that would be minus I squared. These two would cancel out as they have opposite signs, I squared is minus 1, so minus 1 would be 1, and then we would have 1 add 1, which would obviously be 2. So to summarize, if you've been given one root, you can automatically find its conjugate pair. You can find another root. In the last example, we have a similar process, but instead of dealing with a quadratic now, we're dealing with a cubic equation. Now, a cubic equation by default will have 3 roots, okay? Now, not all of them can be real. We could have 3 real roots, or we could have a situation where we have a pair. Remember, the conjugate roots always come in pairs, and then that would mean the third root would have to be real. So what we can do here is we can start by using the previous skills we've been doing and form a quadratic equation, and then we know by the factor remainder theorem, if that's the root, that z minus 1 must be the factor, okay? So we're going to multiply our quadratic by this factor to go from a quadratic to a cubic equation, because there are 3 roots. So here we're going to say z squared minus z times the sum plus the product. So here I'm going to cancel these out, and this is 4. So this would be 4, this would be minus 6i, this would be plus 6i, and this would be minus 9i squared. So here these would cancel out. I squared would be minus 1, so this would be 4 add 9. So it would be z squared minus 4z add 13. So that would be a quadratic equation that had those roots. We don't have a quadratic equation, we have a cubic equation. So I need to find the cubic equation would be z minus 1 times by z squared minus 4z add 13. Okay? So basically we're repeatedly applying the factor and remainder theorem. We know that if these are the roots, these should be the factors, so we can form the equation, and if this is the root, this would be the factor, and then we just expand. I think I'm gonna actually expand this like this. So z times z is z cubed, so that would be minus 4z squared plus 13z minus z squared. Minus times minus is plus, so plus 4z minus 13. You can expand this like this if you prefer. I sometimes like a grid when it's getting bigger. I find it gets really messy. So my final equation would be z cubed here. The z squared would be minus 5z squared. Then here I would have 17z. And here I'd have minus 13 equals to 0. So guys, that wraps this one up. In the next key skill, we're going to be finding the roots if we've been given a cubic equation. Thanks for watching. Please like and subscribe. That really helps my channel. And I'll see you in the next video, guys.